is built to send stuff wherever it wants. That doesn't seem entirely wonderful. So then we've had to basically unwind the whole self-routing one of the initial premises of networking. But why would we do that? And is there anybody else that would want to unwind that basic fundamental premise of computer network?
Yeah, so the thing is, it's not only about the fact that we got bigger and bigger pipes, but a lot of things happened along with it. I mean, not only that it's inexpensive, has become relatively inexpensive, that is one thing. But let's talk about, what have we kind of unwound or relearned in some ways. Because IP networks in general, we were talking about averages in the past, right? It's about, okay, average latency, yes, it'll get there, but maybe it'll take path A, maybe it'll take path B. But what we started to realize because of transitions in many different industries is that we want determinism. I mean,
I'm sorry to interrupt you, but who else?
Who
else wants
I was going to give you an example, which I often use, and it's there on the internet somewhere, so I picked it up somewhere. Think about going and picking from a tray of Twinkies. Okay, you have the cream in the middle, and tell me how often would you like to pick a Twinkie that has cream smeared all over, as opposed to being just nicely in there? No, you wouldn't, right? Because it's all about determinism.
I'm wondering where you're going. Oh, determinism! I got it.
So where I'm going with this is because it's saying that. You have industrial automation. You have machines that are going to put the cream in the middle of the Twinkie. You do not want the cream to be smeared all over. You want it to be right there in the middle so that it looks perfect. So you are tempted to pick that. And therefore, where I'm going with this is that not only determinism is needed in video space, but it is needed in so many different areas. And another example I'll give you is connected cars. I mean, you're going to have cars drive itself. You want it to brake exactly on time, not 30 milliseconds later, right? After you okay.
Hey, in the computer world, that's called good enough, right?
Yes, so the point is that you need the determinism, the need for determinism, the need to change some of the fundamental paradigms of network to look at it a little differently. It's happening from so many different segments. It's happening from industrially, Ethernet. It is happening from connected cars. It's happening from financial spaces that we've heard about. It's happening from this professional media entertainment space. So we get now that's what's causing it. It's not that, okay, I don't have the scale, but that's what's tempting us to IP here is because of the promise and of what all we can do, the newer workflows, maybe the power of the other industries are making happen in the IP space. So that's what I think is really attracting us to moving to IP.
Thank you. So, John, I know you want to piggyback off of this, but also the reason I mentioned the submarine thing is because you won't tell us, and we don't need to know, how much of the submarine's payload was given up to some interesting image processing ability. But has anything changed, have there been fundamental investments in compute brain power, methodology, whatever that kind of got us here?
For sure. I mean, if you look at, I did an experiment for some paper I was writing. I took the curve of Moore's law, and somebody had put together actually, which specific Intel processor really doubled and so forth for about 15 or 20 years worth of processors. And I extended it with another couple generations because it's older. And I was able to tag those against specific products we were able to launch. I said, okay, with those processors, we could do 4 channels of SD on a server. With those processors, we could do 4 channels of HD on a server. With those processors, we could do 2 channels of 3 gig, and so forth. And you can really see it line up. And you say, okay, maybe there was something to that. The hardware got better and better, and things that used to be impossible became feasible, and then became straightforward, and then became actually kind of easy. But there's also an infinite appetite for more. So if we were just doing SD, I mean, imagine that world, right? But if we were just doing SD, we wouldn't even be having a meeting about this. It would all be virtual. It would all be running in the cloud, data centers, and it just would have.
Look at audio, right? Look at audio.
To do SD in software in a data center and all that, no problem. But instead, the world decided UHD.
Yeah. Keep going.
Oh, come on, I kept the broken one.
No, it still works. It just fell off.
So keep going.
It's not
So,
broken.
so you know, instead of
But I'm not going to put my feet on it.
instead of taking the go to the data center model, we said, oh well, there's some value in those more pixels, and HD was good. And just when we about got HD really dogged in and optimized, oh no, gotta do UHD now. And I think Glenn wants to do 16-bit, and he just sees 12 as a crutch to get in there. So
Exactly.
He's nodding yes.
Where are you, Glenn?
So
Nodding yes.
so this.
It's
we
Moore's
keep-
law.
we-
There's always more.
Right, but we keep moving the goalposts too, right? So, but I think the other big change that's happening is if you look at the life cycle cost of building a piece of hardware, you say, okay, I'm going to spend a certain amount of time designing it, it's going to have a certain market utility, and then it's going to be kind of old and useless to sell, but people will still use it, so I have to support it. It's kind of the phases of life. Software is a very different thing. And so as a vendor, I'm sure Grass has the same challenges. We've transitioned a lot of our investment, our way of thinking about things, to software because software has a very different life cycle. And even not just software like that does, say, a video thing, but software like in a switch. If you look at the operating systems of switches, there's code in there that was in there 10 years ago because it's perfectly good, and its life cycle is quite long. The hardware it runs on changes, but the software and the applications, that's where the value is, and we can extrapolate a much longer marketplace life cycle out of the value that we invest in developing application software compared to just being in today we're making Betacam, next year we'll make digital Betacam, the year after we'll make super digital Betacam, and whatever.
Yeah, this could go on for a whole career. This could be good if you time your retirement correctly. Those of us in the room here, may have missed the boat a little bit on that. Thomas, the IETF really developed a lot of the core underpinning standards for that DARPA thing, and for years it was based on optimizing email, and now it's based on optimizing Twitter, chat and email and all of that stuff. In your observation, working with that organization generally, is it just you that kind of brought an interest in video to the IETF, or have there been some other fundamental changes and emphasis generally in that community that have helped support what we're doing? Chicken or egg type question.
Well, I think that you'll find a lot of researchers come up with concepts, and those research things go into the IETF. So the IETF had SDI over IP a long time before SMPTE 2022-6 happened, which I think you guys were aware of. But it was back in the early 2000s was the first RFC for SDI over IP, and then the first decade of the 2000s, they had RFC 4175, which we try to kind of just reference in SMPTE 2110-20. But I have to admit, IETF folks are a little more loosey-goosey than SMPTE folks, so we kind of retook the basic protocol and rewrote it in a proper standards fashion. Maybe we'll give it back to them. Maybe we'll have a new RFC that updates RFC 4175 based on 2110-20 in my spare time.
You could do that.
You can do that.
So they've been doing this for a while. And, RTP has been around for a very long time. Since about the year 2000. It's something that people have wanted to do over the internet for a long time. As soon as the bit rate was achievable, that they could get some type of useful compressed video over internet connections, RTP came along. Generally it started with on-premise internet connections. In other words, IP within the enterprise. And I know CISCO did a lot of early work with RTP very early, and of course now we've moved not only with RTP but with the web video standard, WebRTC as well. So there's definitely been a lot of work, and I think there's a recognition in the networking industry that the internet is no longer about moving packets and web pages. It's about moving video, right? There's so much of all of the traffic across the internet on the planet is all people watching Netflix videos, and they're watching Amazon.com Prime Video. It's moving to be mostly video, and almost just a little baby bit of data is left. So I see some of the major changes coming along is really on the software side. And I think we have been, this industry has been using huge monolithic blobs of software for a while. And that's becoming very uncool these days in most enterprises, right? So we've got an automation system, we've got a traffic system. If you look at something like Amazon.com and the way they work, they have what they call microservices. They build these little services, and each one does a little small thing. And that way, you can compose these microservices together to create a full level of functionality. And the other nice thing about it is if a microservice has a bug and you need to fix it and you need to roll out a new version, you just roll out that new bit. So imagine you've got, let's say, a secondary event that has a bug on in your automation system. Today, it's like, hey, I've got a bug in my automation system. Like, well, okay, 6 months from now, there'll be a new release of the software. On the other hand, you go in, you fix that bug on that particular issue, and it's done that day, and you do continuous development and continuous integration of those microservices together. Now, I think that's a big change that we're going to have to make, and there are certainly some efforts within the broadcast industry to say, well, we need some microservices for, let's say, doing graphics compositing. We need some microservices for doing closed caption sending, things along those lines. So this is all coming.
Yeah, I don't know how we keep our vendors in business in that model.
We're all about it. It's not as though this is news, right? So we all have, as I mentioned just a moment ago, software is where it's at. It's where the investment is, but it's also where the functionality is. At some point, we love making and selling boxes. Don't get me wrong. As long as you want to keep buying them, we'll keep selling them. But that said, the new stuff is applications running in virtual container environments, and sometimes they're microservices composed, sometimes they're more traditional, but it's that's where the work is. The software, moving the signals into IP by itself is like the halfway to the rainbow. If you just do that, and then you turn it back into SDI to plug into all the stuff you already had, okay, it solves a scaling problem if you had a scaling problem, but it's otherwise just what it is. It's when you can move to deploying the applications or microservice bundles in flexible computing resources, then you have something. Then you're like, okay, during prime time I can spin up 17 master control threads and really paint the country with very targeted ads, and then at midnight when everyone stops watching anyway, collapse it back to one thread just to stay lit up.
So let's poke around on that a little bit. So one thing that I've noticed that changed, which I mentioned earlier, is I got 4 new versions of software for my iPhone in the last week.
That's only because you installed them. If you just ignored
You
it.
could just yeah, very true. And by the way, my VPN no longer works after I installed the first one, but let's not go there. But can someone speak to what happened to computer science? I mean, we were going along great with these monolithic things where you would sit down and you would crack your fingers, and then you'd pick up a brand new deck of punch cards and you'd put them into the typewriter, and then you would start typing, right? To this thing where you've got these, I don't know, they talk about these Lambda thing and event buses, and I mean, obviously something happened, and now we're talking about these things where you just, you plug in this and you plug in that. Can some or all of you speak to what happened to the computer wackos?
Sure, let's go in order again.
Yeah, go ahead.
We all remember the joke. I'll date myself. The joke was, how do you keep a software engineer busy? Hand them a bottle of shampoo because it says wash, rinse, repeat. Yeah, see, we're establishing commonality in age group, aren't we here? So if you think about that, technology just goes in circles. The key thing about that is trying to sort out the time constant of how quickly it's going to spin around again. So I started computing with a centralized mainframe, then we spun out to PCs, then we're going to pull it back, we're going to put it in the cloud, now we're going to pull it out, we're going to put it in a fog, now we're going to... It's going to spin in this kind of a circle as different applications migrate into the technology backbone. What's happening, though, is that the radius is collapsing so fast that you can pick the technology you need. That's empowering. Before, I only got the technology that was there at the time. I was forced to go do it on a PC. Avid was the first, I guess, maybe, who really commercialized the desktop editor, and once they showed it could be done, everybody was forced to have to do that. Because that was the platform that became ubiquitous and I could recognize it. Going forward, if you have an abstract world, I could build things in 3 different ways. So I can choose the one that gives me the best bang for my either OpEx buck or CapEx buck. And I get to pick. And you're going to get to pick. And so it's going to be an interesting decision space because you're going to pick a vendor and you're going to pick an approach. I mean, we had a debate. Is it 25? Is it dual? Is it multiple streams? Or is it light compressed? It's all. It's all. What's the size of your wallet? What's the feature set you want? And when do you have to go on air? And I can guarantee you they're in this order. The size of the wallet will dictate the day you go on air, and what you sacrifice will be the feature set. Truth. Truth. So the point is, you're going to look at this suite of tools that are available to you. You're going to build what you want to build, and now the flexibility of IP is what enabled you to do that. Microservices are what let you go after that and let you pick and choose the pieces that you want. And just my last little thought piece on all of this is that the compute time is so fast, it's irrelevant. It used to be compute time was meaningful to me as a human being. Now it's so fast, it's almost a wasted resource. Cost of memory, almost a wasted resource unless you're renting cloud space. But once again, you're back to a financial trade-off. But you're not worrying about fundamental things like compute cycle time. You're not worried about bandwidth. All of those things have become don't cares. What you're worried about is the cost and how you're going to optimize that to deliver the system you want based on the suite of tools that's ready to get you on air.
So I think I heard you just say, given infinite money, there's infinite compute and infinite bandwidth.
Well, see, yeah, if you have infinite money, the triangle's a flat line. And you get all the features and you make any time to market, right?
Right, but I mean, what's changing is that now that money angle, we're probably getting too literal. The cost of those things is such that you can say almost virtually infinite compute, virtually infinite bandwidth, as something that you could, as with grass, something that you could actually start to be thinking about when you're making product.
The internet has gotten us addicted to immediacy, and then choice, and last, quality is not a standard determined by any of you, it's determined by me. Yeah. I choose my quality. And that's why half the video in the world will be on this in a couple of years. There's more than one study. So we're going to stream it, we're going to be there, because this is my selected quality the majority of the time.
Yeah, well, we now have 4K HDR phones, so we will still be 4K.
But to the point of what are the games you're going to play and how you're going to do it. So yeah, absolutely.
If we want to, let's just go down the line.
Yeah, the thing is that you talked about infinite money, but there is another factor that might influence that, which is that just as you're not going to have a choice of which vendor you pick or what microservices you need, your customers are going to be able to do the same thing because with the amount, with all this data that you can actually collect live from all your viewers, and that is not some kind of dream that's happening in many industries today, that you can collect all that big data from all of these viewers, and they may have some choices, so they are going to be voting with their wallets. That is what you have in the absence of infinite money, because you are getting immediate feedback or immediate choices or requirements from your customers who are viewing in maybe one of many devices as they're going along, and that is going to dictate what you build or what you serve and so on, which in turn is about the flexibility in terms of how you put these services together, which as John was saying, the vendors will build all these microservices and build you software, and there is business there. So the point is that we have to recognize that the moving to IP is going to give us that power of feedback and the power of the requirements, which is going to be a lot more extensive or direct or even live as compared to the previous methods because of big data and other things. I mean, this is happening in many other industries. I mean, I just talked about connected car a little while ago. People are actually collecting feedback or data from cars, which are millions of cars, even if you take a particular model. Now, so scale-wise, that is not a whole lot different from viewers, for example, so of any particular program. So I think that is going to be the one that eventually, I mean, all of that is going to drive the choices and the flexibility of how the software is offered or what software you want to pick and choose.
John?
So we all exist inside a larger economy, and that economy is driven by viewers. And in the end, those viewers and whatever it is they want to watch on whatever device they want to watch it on, that is the economic source that then feeds all of us. And that's both a blessing and a curse, right? Because there's a lot of viewers, and there's more of them every year. Population keeps going up. But at the same time, what they want is very different. I mean, I have, kids in their, late teens and early 20s, and they don't watch TV. That's very frightening because sorry, they don't. They don't care about the NFL. They don't watch baseball either. They just,
baseball. For shame.
But they watch lots of something. I mean, they spend more time staring at the screen than I do. Okay, but what is it? They're watching Twitch. They're watching other gaming channels. A lot of red team, blue team, or it's all kinds of stuff that's delivered through IP and through software, but it's not traditional television, it's not traditional sports. And so as we work with our friends, the media producers, they're all about that, right? I mean, if you look at the whole broad spectrum of channels and features that Fox has, or CBS has, or ABC has, or NBC has, there's traditional television, but there's lots of other stuff there too chasing those markets. So what that drives us as vendors and you as content production professionals toward is how do we serve all those different parts of the television marketplace or whatever media consumption marketplace you want to call it with a common set of fabric. And that's what's driving this, is being able to build facilities that can flex to more of, to more different content in more different delivery formats instead of just optimizing how do I make the core channel better, because we can't save, as broadcasters, you can't save money into the future. You have to figure out how to find and continue to chase the whims of the consumer.
Yeah, true. And it just as maybe the exception that proves the rule here about the baseball thing, I want to breathe a little bit of life into the people who fell over in the audience here. My son is 21 and he's off at college except when his laundry pile becomes too high, in which case this person reappears in my house. It seems like a bear raids my refrigerator at like 3 in the morning. But one of the interesting things about his baseball consumption habits, because he loves baseball, is first of all, he never watches it on something like this. You're right about that. Second of all, if it's an important game that he wants to watch, he watches it like this as he's walking to the washing machine to take stuff and put it into the dryer. And the third is that when he's not watching the game, there's this like baseball podcast that drifts, the sound of it drifts through my house, kind of from his room out to the car as he's going off somewhere, comes back through this way. And those guys have cameras and all, it's a full-up podcast, but he just sticks it in his pocket and he's just listening to the thing as, he wanders around living his life. So I think that you're exactly right. The programming is still compelling, but the consumption models are like, what? And he's just one example. So the red team, blue team is another, all of that. So Thomas,
well, you're asking a good question. What went wrong with computer science? And this is a major issue. So what happened was this software became too big and too complex. Now there are several worlds of projects out there where every little thing has to be perfect, and every little thing relates intimately to every other little thing. So on a Falcon 9 rocket, if the bracket holding the helium tank has the least little problem during the peak acceleration of launch, that bracket breaks, the hydrogen tank comes down, hydrogen tank bursts, the whole rocket detonates, and you get lots of little pieces of metallic dust spread, off the coast of Florida, right? That's the kind of project you have to do in what they call the waterfall mechanism, right? Where you collect all the requirements, and then you go through and you do the work breakdown structure. You're very careful to make sure that every single task gets done perfectly because they all interrelate to one another. Most software is not like that. So, for instance, if I've got an app and it doesn't ask me my name, that's fine. I can later come in and put in something that asks me my name, right? Might not need to know my name. And that drove Agile. Agile is a project management system for software, and the concept is think about what you need, what's most important, and what delivers a quantum of business value, right?
Minimum viable product.
Yeah. Minimal viable product.
Bless you.
So spend a few weeks with your team determining that minimum quantum of business value, deliver it to the customer, and repeat. Go back. Okay, so then say, well, what's the next minimum bit of quantum of business value that needs to be coded? And that's where we are today with most systems, except for the ones that we tend to use. Most software out there is being written, in an agile format. And of course, microservices is the next step beyond that to make sure that as you're putting together these quantums of business value, that they don't have strong, deep relationships that could cause significant problems if one part has to be redesigned.
And
you don't have to redesign the whole rocket.
So I actually want you to burrow into that a little bit, because I wanted to explore this some. So that's one, is separation of concerns and proper layering and proper architecture and all of that. You mentioned big data. There's also event-driven architectures, and PubSub and all that. I want to spend a few minutes talking about that, because there has been some really fundamental changes in computer science. And I think we are going to become intimately familiar, like it or not, with the good, the bad, and the ugly around those fundamental changes. So I'm going to ask you to just go into a little more detail about that, and then I know PubSub is one of your big things, and you already mentioned big data, and so whoever wants to pick off some of these things, let's burrow down into that a little bit more, please.
Okay.
So, Thomas was going there about separation of concerns.
Well, yeah. So the concept is have every little bit of functionality within your software system be separable to the extent it can be. Sometimes you have to share data structures in a database or what have you, but have it be as separable as possible so that if you need to change this part, you can change that part, and you don't have to recompile your entire system and deploy it as one big chunk. You just continuously deploy and continuously integrate new sub-chunks.
So, Chuck, I used to call this subroutine, and I would say, get some value of some plumbing fitting somewhere in return. But how do I do what Thomas just said when that subroutine that's, getting some value from some plumbing fixture somewhere isn't written by you?
Right. So this was kind of something I was frantically trying to hold up my cell phone about earlier today, because I thought it was the perfect example.
We've gotten to that time. Yeah.
So part of the JTNM architecture was when we got up to, first thing we wanted to do was abstract the infrastructure. Then on top of that, we had to build a platform. And so in order for all of these microservices to be able to interact, there's a concept, and it doesn't have to be done this way. There's lots of different options. Beauty of IP technology, there's so many options. But we decided to take identity, and you drill on identity, and everything has a unique identity. So rather than a subroutine saying, oh, I know what my subroutine is about and it has the following variables and IJKL or integers, et cetera, then what I can do instead is I can just go out and I can say, okay, what are you? I have your identity. Well, why don't you tell me what you can do? And then I can respond back and I can say, you know what, these are the things I can do. And sometimes this is called ask and answer. Sometimes it's called publish and subscribe. So basically the idea is if I'm a device, I can publish my capabilities and my versions. So as a user of that, I can come back and I can choose to subscribe to it. And in addition, I can subscribe to it based on knowing what level we're able to communicate at. And through that more complex negotiation process, this is how I can stack new APIs on top of a fixed data plane. Or I can stack them in a way such that they can work with each other. So this is one of these things that's changed, right? We used to write hard protocols. Absolutely, good Lord, Envision 1990, ES bus, right? There's a SMPTE standard for you, right? We all tried to write something to ES bus, and we all found out that it only solved 80% of our problem. Now, instead of having PubSub to solve the other 20%, Howard would call me up at Envision and say, Chuck, I need my router to do ... And we'd go in and we'd handwrite code to fill out the balance of the protocol. Extremely powerful technique. And it enables microservices, it enables flexibility, it allows us to get what we want to do.
And just to go into that a bit more, then I'll come to you, Subha, and John, you too. So just an example, if I'm old school Brad, yes, I'm old, ask my son, I'm going to go out and write a function thermostat, right? Thermostat has got heat and cool and fan. And so I write this application and it does heat and cool and fan, and that's great. And then some Honeywell bozo comes up with dehumidify. It's like, great. Now I got to go rewrite my application, and now I've got some equipment deployed that does, heat, cool, and fan, and I've got some other stuff that understands heat, cool, fan, and dehumidify, and it's just a mess, right? Or I can look at capabilities, and I can use what Chuck was talking about, which is tell me what your capabilities are. And if you go find a device that has the capability of humidify, and you happen to know how to deal with humidify, you're golden. You actually don't have to change anything. And this is a fundamental change in the way programming is done. So that's an example of what Chuck is talking about. Subha and then John.
Yeah, so what Chuck was talking about, in many ways it's also called service discovery and services, right? But there is another aspect to that, because it's not only about discovering the services. Chuck covered that, and Chuck and Brad covered that very well. You discover the services, then you can use those services. But there is also service chaining. So it's about chaining certain set of services, and you don't have to chain the same set of services the same way for every operation. So for example, if you have, we talk about dematerialization quite a bit today. It's about the cloud and virtualization, but it is not merely just taking all that workloads that you had locally and moving that to the cloud, but it is also about building these service chains. So you might need one flow to go through, let's say it is 2022-6, you want to convert it, you want to do 2110. So you actually go through that service, you chain that as part of your service, and then maybe you want to do frame sync, maybe you want to do color correction. So you chain that set of services. But maybe for another one, you want to do SDI to IP chaining, so you bring that service in and you can chain it. So the whole point about doing this in a virtualized way is that you can go and fetch the services that you need, and then you can chain the services that you care about. So each workflow can be fairly independent. And now if somebody comes up with a really brilliant idea and you want to incorporate that, well, that can be incorporated because that will be a new service, and any services, any chains that need that service can automatically include that. So the thing is that it makes it easy, first of all, to have different services in a chain, kind of uniquely based on any particular flow. And then secondly, it also allows you to either add a chain or delete a chain as the case may be. Now, if you have an IP-based camera, maybe you don't want this SDI to IP, so that part of services might not be as part of the chain. So the whole thing is that the service with the service chaining and with it being virtualized, so you can spin up as many VMs and not, gives you so much power to not only do the workflows you have today, but gives you that environment where you can add new workflows, new services without actually having to, construct everything all over again.
How about it, John? We're in New York, so
Yeah.
the BS detectors are fairly
Yeah,
high. And
no,
I'm not
it's-
saying anything except, what you guys are specifically tasked with doing the sorts of things that Subha just talked about.
Yeah, it's very much, what we call today microservices are the follow-on of the thing from, 10 years ago called service-oriented architectures. And so microservices is, okay, let's get the services to be the right size for the things so they compose. And that's a big thing, is picking, how small or big the service chunks are, so you don't spend all your effort chaining and you get a meaningful amount of work done in each one. When we talk about, you could do this, you could do that, the challenge I think we face as an industry is, as television professionals, we want to go from program production says, we want to try this concept of how to create this show. And as the engineering department, you want to be the department of, yes, we can do that, and I'll whip it up, and can we have a meeting Monday about how to do it? As opposed to, well, that's going to take $6 million of capital.
Yeah, let me give you
and
the
call me
list
a
of
year from
reasons
now.
you cannot do that.
We have to, sort of, that's the transition from being the department of no to the department of yes, right? Or yes, we can, and here's how, or whatever. So that's where these, this microservice stuff is how the flexibility happens. It's how you can say, okay, to do that extra feature, to add that third graphic, to add that other thing that somebody invented, you say, okay, well, we just have to write a service that does that and contract that out. And, Joe from services knows how to do that, get it done in a week or two. But it's a very different mindset, because historically we'd spend years designing maybe a year, designing the new building, and then we'd wire it for 6 months, and then we'd operate it for 8 years or 10 years, and then we'd do a little refurb, right? And then that whole time scale is different. Now we're going to design the fabric, we're going to design the networks and the computing environment, but the actual chains of computation we have to expect those to be dynamic. We have to expect those to be a subject of continuous evolution. So this, continuous integration and agile development isn't just something that, we on the product side do, but then you buy a box with a spec. It's really something that also happens in the entire workflow of the facility, and is every couple months or every couple weeks, there's a sprint and a change and now we're going to be able to do this, now we're going to be able to do that. A continuous evolution of capability in whatever direction the marketplace needs it to go.
So let me ask you this, John, from specifically on that topic, from your perspective as a vendor, this sounds like potentially an ideal way forward, or whatever, this microservices thing. But I can imagine a number of ways that this is actually really hard.
Yeah.
What are some examples of those ways? Because I know you're being challenged in some projects to specifically fit with that model. What's hard about that? Because Amazon is built that whole way. They've already done it. Google does that all the time. So what's hard for us?
What's
hard
taking so
for
long,
you?
You're saying, why aren't we there yet?
No. Actually, and that's a good point. No, I'm not saying that. I'm asking a genuine, serious question from where we are. And I think part of what's really important like I came from Turner and other, people who are on the user side space, we don't live the vendor world. We're going through our own changes. We're going through our own evolution of our businesses. That doesn't necessarily mean we really have good visibility into what's going on in the vendor space. So I'm asking a legitimate question. This sounds like a great thing. What's hard about it from your perspective?
To me, I'm interested in Chuck's answer too. To me, the hard part right now is that we together, all of us, are, I'll say, changing or finding or fishing for how are we going to all do business together in the future. Because for years and years and years, it's been, here's a data sheet for a box that has a price, and because the sales guy likes to buy you steak, you're going to get a great discount. And then that box is going to meet that spec and sit in your rack for 10 years, and you'll buy a service contract for the first 2 of those.
And what's wrong with that?
I
I mean, other than you have to build the price of the steak into the product. But
anybody who wants to continue buying gear that way, please see me after class. But you know, the world evolves faster than that, and the need evolves faster than that. So we have to find what is the new normal, and the new normal could be, you know, some kind of continuous integration process. The new normal could be a completely as a service model. You know, just keep putting quarters in, and television keeps coming out. And if you want a new feature, we'll talk about how to do that. You know, it's anything along that spectrum.
Yeah, and if you quit putting quarters in, we revoke your license. Let's not go there. Anyway.
Which part of it? But that,
yeah, right.
to me, that's one of the underlying challenges. You know, from a technology standpoint, we do anything.
Well, sure.
Right?
Yeah.
It's a question of what can we do together in a way that's mutually useful and actually provides a business model that allows customers to be healthy and the vendors to be healthy enough, you know, just healthy enough, yeah, and so forth, so that we can all move the industry forward together.
Yeah. Chuck, he was curious to hear what you had to say about that.
You know, probably in summation, it's very close to what John's saying. I'll use a different metaphor. Way back, the choice you had to make was 50 Hertz PAL or 5994 NTSC, and they were both interlaced. That was your choice. Pretty cool. I build A, I build B.
And there is CCAM.
System essentially contrary to the American norm.
Dematerialization.
No. See, I even know what it's called still, right? Okay. You forgot PAL M. Anyway, let's forget the obscure children.
Two, good.
We had two. Question ahead. Now we got 1080, we got 720, we got Ps, we got Is, we got 60s, we got 24s, we got 2398s. And every one of those expands the range of everything we have to do. Now we're going to expand that again. And I'm not pointing at anyone in particular. You want one format, you want a different one, you want a third one, you want a fourth one, and you want a fifth one. And I'm supposed to get them all into this IP wrapper at the identical point in time because you all have your different business model because of what I said the last time I spoke. Most of us didn't typically go about designing a product in a way that was accommodating of easy extension because most of us thought about the Fortran subroutine, call PAL, call NTSC. We didn't think about the publish subscribe, or we didn't think about, because somebody said orthogonal. Matt, you said orthogonal earlier today, so I get to say parametric function.
It's a long-running private joke. Don't worry. Press on. Parametric, what do you mean?
So what I mean by that is, I'm doing all the same things. Like John said, it's not the technology. I'm doing all the same things, but I could have built a video processor where I said, tell me your frame rate, tell me your aspect ratio, tell me your pixel count, and now I know how to program the engine as opposed to pick PAL, pick NTSC, and everything's pre-programmed. Had I built the latter machine 10 years ago, I'd be pretty darn happy today because I'd be much more adaptable. As we look at what we have to build going forward, I think we're all looking at things that are much more adaptable so that we can be more accommodating to your request for customization. We don't get it all right. It's got a little more runway for us to get off the ground, but when we get there, we get to where you're trying to get.
Okay. I want to open up one other subject just to poke around on it for a minute, and then I think we're going to kind of be wrapping up. And I was going to ask for questions, but geez, these guys just are doing such a great job. I wanted to let them run. Two things. When you look at the internet and what's going on, you've got, among other things, big data and messaging. I mean, a lot of messaging, just huge volumes of messaging. Subha or Thomas, what are your, or maybe both of you actually, what are your observations? Are those fundamental things, can you foresee them impacting us?
Well, I like to talk about logging and big data analytics. So, you know, so recently, as we start getting with this whole IP thing moving forward, a network vendor came to me and said, so how often does your SDI routing switching switch? And I'm like, that's a good question. How often does my router switcher switch? So I went to our maintenance people. I said, oh, so do you have logs on this? Like, logs? It's like, I think I can screen scrape something. Whereas, if this was any other type of software that was running like in a cloud-based environment, we'd have logs up the wazoo, right? And we'd have terabytes. We'd have a data warehouse or data lake with all of our stuff. We could do all the analytics we wanted to. I could bring it up in a Tableau, desktop, be able to see everything on the dashboard. And we're just not really thinking that way yet. Now every now and then I hear some people in the broadcast industry really talk about this, but we have to think about, we've got all of this equipment. And first of all, with ISO 4, we'll now know what equipment is plugged into the network in our broadcast plant because they'll all announce themselves, right? So we'll know everything that we have. So there's at least an inventory problem that's solved. But then we'll be able to log everything all these devices are doing. And then we can go back and we can say, like, oh, something's screwed up. Can we go back, look at the logs, and see what's screwed up? Or we can say, you know what, we did things this way for this game. Let's think about how we can be more intelligent about using our resources for the next game. Or I know how much this cost because I did it on, let's say, Amazon Web Services. I know exactly how much I was charged for every transcode I did for this business. Can I, now somebody comes along, wants to do that new business again, I can tell them exactly how much it costs. So there's a lot of power in this, and I think that it's something that the industry really needs to get behind and embrace, is that, take good logs and then go do good analytics on those logs.
Yeah, good point. Subha?
Yeah, so I think it's going to open up a lot of potential for newer functions and workflows because the ability to, like, for example, over-the-air updates for software and a lot of these things, so you don't have to go and, if you have bought a piece of software, you can get just like you're getting on the iPhone. So, and then you get all sorts of statistics back or maybe even preferences back that will cause you to make some choices as you are even maybe in the middle of a live programming. I mean, these are areas that I think is it's a lot of potential for innovation right here because the technology is moving and is being incubated and progressing because of various other factors, and including big data. I mean, big data used to be large pipes and so on. There's so much of new innovation going on there about how you can you might have big data, but you can recreate that big data out in the cloud, but you are only sending very, very little across the pipe, across the wire. So there's a lot of innovation going on in that space. So how all of that can be leveraged, I think, is something that we will, once we get past this table stakes of things that we are trying to do, I think that opens up a whole lot of, possibilities of innovation. I was involved in the voice over IP transition right in the beginning. I've had, while I was in the middle of that, there were people telling me that absolutely we cannot, we have this huge quality of service requirements. We need a separate network,
so
and it has to be overlaid.
People told you it's never going to work.
Yeah, it's never going to work on a thing. And moreover, anyone know what an ISDN to IP gateway is? I worked on it, and I put quality of service on it. So like that, I'm sure that there will be a time when we are asking the question, SDI to IP gateway? Does anyone remember that? So it is going to come to that. So the point is that we might not recognize it while we are there, like we didn't when we did the voice over IP, but look at it now. We are doing WebEx and screen sharing and whiteboard sharing and all of that stuff. We never really thought that those were even workflows at the time of doing that ISDN to IP gateway. So like that, I believe that there would be so many new innovative workflows and solutions that will help this industry, to use John's words, be healthy.
Thank you. Go ahead,
There's
John.
one more big data thing that we tend to overlook because we're infrastructure people, right? But on the distribution and consumption side of the business, we're getting closer and closer to individually targeted ads, and to having the ads really be that consumer's seeing that ad for this reason, and it ties into which programs they watch, it ties into what they watched before, what they watched next. So the whole big data application on the advertising side of our business, remember that advertising is what feeds us and pays our bills and everything else. There's a huge big data application on that side of the fence of tracking and retracking and analyzing what's the best ad to show that person. And all this time that everyone's walking around watching the video on their phone, what they really are saying is, I'm a targeted user, you can send me the right ads separate from everybody else. That's something that helps us all.
Absolutely. With that, we'll conclude. I mean from the bottom of my heart that it's an honor to have been able to just have an open conversation and ask you guys some questions. Please thank our panelists.